So to wrap things up, we're going to create a final render of this effect. I'm going to actually bring back the sky dome, so we have a backdrop upon which to work, and I'll move into my render options. And the whole effect, if we just play it back, we'll start it around frame, let's see, I guess we can start it around frame, say 56 or so. So we can set it as our initial state. I can grab my point cloud. I'll set that as my beginning frame. And so from there, we get the start of our particle simulation. We can also tune the effect a little more if we need to. In the rigid bodies operator, we can set the collision precision a little higher if we need to. So the effect here, if I continue to let it play, let's just see how everything works. Should be done by, it looks like, about frame 250. So I'll let it run from 56 to, or in this case, from frame 1 to 300. So I'll set up the final frame of the render. Scene options, 1 to 300. I'll make sure I'm rendering in my custom format with my render pass called Falling Rocks. I'll let the render go from here, but just to add one more thought to ponder, this is an effect that you could have also just done with pure rigid body dynamics and then used ice to create the particle emission at collision between real geometric objects. So it really depends. I'm actually using ice here because it's a new tool, and it's always nice to see what we can do in ice versus the rest of the XSI interface. But in either case, we could have used the internal rigid bodies or the ice rigid bodies. At least this showed us how to work with the mass between two different particles in two different states within the same point cloud. So I'll sign off here for now. We'll have a look at this render when we come back from our render.